So in a quadratic, we're going to deal with two solutions, one solution, or no real. Two solutions have two roots, and remember, sometimes they can use zeros. On the park, they use the term zeros more than roots, but I have seen them use it interchangeably. Okay? One solution, you would have one root or 1, 0. And what do you think no solution? You have no roots or zeros. Okay? Remember, those vocabulary terms are used pretty interchangeably. I can't just say there's one use for everything, but okay. So two solutions. All right. We have to solve by graphing. So what's our first step when we solve by graphing? We have to first find the axis of symmetry by doing opposite b over 2 times a. Okay. So we're going to get -3. All right, so I know I have my axis, my vertex is going to be -3 something. And then I got to plug that in. Okay. Remember, it's crucial that you do -3 in parentheses, especially if you're going to deal it on a calculator. Because if I just did this, okay, I get -9, but why do I get two different answers? Case? Excellent. So here you do 3 squared, and then that's like kind of like a -1. It's almost like your calculator is doing this. -1 times 3 squared. Okay? You know, it looks weird, but that's just how it is. All right, so then I have my vertex. So we're going to go to -3. 1, 2, 3, -1. Okay. Oops, -1. That would help if I plotted right. All right, so remember we can use, so we got our line of symmetry going on here. So what's my A term here? 1, so I can just keep the pattern 1, 3, 5. So up 1, over 1, up 1, over 1, up 3, 1, 2, 3. And since this graph is just, this problem is asking me to find my solutions, I don't really need to do that many points. So my solutions, my zeros, are what numbers?
-4.
Very good. -4 and -2. Okay. We could have also solved this by factoring. This one works out nice by factoring. Actually, no. Yeah, it does. 4 and 2, and then we could solve that. But, and then you could graph it. Another crucial one where when you're plugging in, you want to use parentheses because that's how I get -16. I don't want to take -4 squared to get +16. So I got my vertex as 4, 4. My A is -1, so I know my pattern would be -1, -3, -5. And now I know my roots are 2 and 6. Today for homework, we're only going to have one x-intercept. So again, we're going to do find your y, or your line of symmetry. So 1. So I get 6 over 2, 3. So equals my x. So then I'm going to do 3 squared minus 6 times 3. Sine. I get 0. Okay. So 3, 0, 1, 2. Okay. And I know again my pattern. Remember, make sure you're drawing arrows. So here I only have 1 0, and that is 3. So try to do, then again, when you plug in, you got to make sure you use parentheses, and I'm going to get my 1 0 as my vertex, and I know I'm only going to have 1 0 which is 1. And remember, my C term is -1. That's your y-intercept. So it's a good day to check your graph to make sure that, okay, I came across it by y-intercept at -1. Okay, so no real solutions for graphs. These are going to look, they're going to still have a vertex and everything, but they're just not going to cross our axis, which is fine. So we're going to do -2, or +2 over 2 times 1, 2, so I have my vertex. And then I got to plug in. So I got 1, 2. And then I know my A term's 1. 1, 2, 3. Again, my x-intercept is 3. 1, 2, 3. And my C term's 3. Good check. Make sure I'm doing it right. So zeros, there are no zeros. We can say no solution. Okay? And then down this guy, we're going to do opposite 4 over 2 times -2. 1. So I get 1, -3. And then go graph that. 1, 1, 2, 3. And remember my pattern here, my A is -2, so I'm going to go down 2 over 1.
Cut the office to Andrew Lynch, Talia Napolitano, Jack Fitch, Elizabeth Stang.
I don't cross. Again, my C term's -5. 1, 2, 3, 4, 5. And I cross at -5.